Good afternoon, ladies and gentlemen. I hope you guys are all having a good day today. So this is the second video that I promised on this topic. So our photoelectric effect for graphing. So ladies and gentlemen, your favorite, more y equals mx plus b. You guys are always excited for that. Who wouldn't be? Right, I know. All right, so ladies and gentlemen, let's go through this. I am going to make a few assumptions here while we're going through this. I'm going to assume you've tried this question on your own. I am going to assume that you guys know how to calculate slope either with your stat plot on your calculator or with your standard slope equation. So I'm not going to be going through those aspects in this video, just the topics that are relevant to this scenario. Sounds good? Awesome. All right. So, ladies and gentlemen, so these here are a couple of review pieces from the previous note that we're now putting, or previous set of notes, previous video, whatever you want to call it. We're now breaking it down into our graphing pieces here. So a manipulated variable and a responding variable. So remember which one is which. X, Y. Okay, so ladies and gentlemen, if we're going to have our frequency as our manipulated variable, if we're going to increase the light frequency, we can expect an increase in kinetic energy of the electrons. So that's from yesterday. And if we're going to be increasing the intensity of the light, then we are going to have an increased current, so more electrons. So those are some important topics that we looked from our previous video. So if you have any questions about those, go back and relook at that previous set of notes. Okay, so we can also put these into some graphs. So for this one, notice some of the titles. We've got a few cases here. Now this one is if our frequency is greater than that threshold frequency. Okay, so ladies and gentlemen, once again, please forgive me, I can't draw straight lines on this thing. So our energy and the intensity. Remember, ladies and gentlemen, that energy and intensity are independent of each other. Okay, so this would be assuming that the wavelength or frequency is going to be the same. Now for this guy, if you're going to have frequency being less than the threshold, well, we're going to have no energy because the particles are not going to be removed at all. So you can make the light as bright as you want, but if that wavelength / frequency is not above the threshold, then nothing's going to happen. Okay. All right, so we're going to scroll down here. So another piece here, ladies and gentlemen. So our current versus wavelength of light. Now remember that the current is proportionate to your intensity. Okay, so in this case, what's going to happen is the current is going to stay the same as our wavelength gets larger. Now remember, when wavelength gets larger, frequency gets smaller. Okay. So our wavelength gets larger, frequency gets smaller, and guess what? We're going to hit a point where we get that threshold, and we're then going to get no current. Okay, so that dotted line is our threshold. Sounds good? Cool beans? All right. So, ladies and gentlemen, we are going to look at our usual case here of an actual graph with actual data where we are going to get our actual slope. Awesome. Okay. So, whoops, I need to be on the mouse so I can scroll down. There we go. So, ladies and gentlemen, here is our example, our lovely example. We've got a big, beautiful graph here. All right, so ladies and gentlemen, there's a couple of different things that you can do with this graph. When you go ahead in the notes, which I hope you printed out by now, you are going to see this graph here, and we're going to be answering these questions regarding using this graph. Okay, so I'm going to zoom out a bit so we can kind of see the whole thing here as much as we can. There we go. All right, so now once again, I've got a terrible time drawing straight lines on this. as I'm writing over here on the tablet, like off to the screen and down this way, and looking over here at the computer, and on my notes, it's trying to get a ruler to go. We've tried it, I just can't seem to get it. So please forgive me. My line of best fit is not going to be straight. It's not the one I've done my calculations off of. It's going to be the best we can for my tech skills based on what we got. All right. Okay. So ladies and gentlemen, you don't have to use your slope itself or graphing method this way. You can use your stat plot, and you can also use your graphs and your extrapolation feature as well if you need to. Okay. So we're going to draw a line of best fit because we can. Okay. So here we've got the kinetic energy of the photons in electron volts. And we have the frequency of the incident light at times 10 to the 14 hertz. Now your line of best fit is going to, please forgive me for the messy line, it's going to be like that. Well, ladies and gentlemen, I'm going to keep bringing it down. Okay. All right. So, ladies and gentlemen, the reason why I brought it down here is because I want my B value for one of the future questions. Okay. This is really not the best line of best fit. It's kind of angling upwards. Let's fix that a bit. As I'm not taking into proper account some of those bottom lines. Let's try it again. It'd be so much easier if I had a ruler. Okay, kind of like that without a ruler. Okay, and I still don't like that. Yeah, when I did this before, I had B of a much different value here. Okay, let's try this again. We want this to be, I'm having a terrible time with this, guys. Please. Okay, that's, it's as close as we're going to get, guys. Okay, so ladies and gentlemen, once you guys have your line, you can get a decent visual here, and we've got our slope, and we have our B, and you can then either calculate your slope using a line here, or you can use your y equals mx plus b with your snap plot in your calculator. So I'm assuming you guys were able to calculate the slope. When I calculated the slope, what I got is our 4.18 times 10 to the power of negative 15. Now, I want you to look at that number, and I want you to think for a moment what that number looks like. What does that number look like? What is it close to? It looks kind of close to the value of H, doesn't it? In electron volts, not the units. So when you pull out your data sheet, okay, when you pull out your data sheet and you go to your back page here, you should be able to see your lovely constant. Okay, so in your data sheet, you've got the 4.14 times 10 to the negative 15. Well, 4.18 times 10 to the negative 15, and once again, electron volt seconds. So that's pretty darn close. Okay, now you probably have a number that is a little bit different than mine, and that's okay. But it should be in this ballpark. If you have a slope of 2, there's the problem somewhere. All right. Okay, so once again, I'm assuming you guys are comfortable with calculating slope. All right, so let's look at number 1. So what is the significance and the meaning of the slope? Okay, well, we've already said it looks like H, but let's prove it. Let's do some formula rearranging and prove it. Okay, and it says using linear regression, so that means I want you to put this in y equals mx plus b. Okay, so let's prove that this is H, and just saying, hey, the number looks like H. Okay. All right, so we're dealing with the photoelectric effect here. So that means we're going to have our energy, that's our incident energy is going to equal the energy that's going to be leaving in those electrons. So our incident energy is going to equal the EK max of that electron plus the work function. Okay, so let's go back to our graph and think about for a moment how we need to sort this out into y equals mx plus b. Well, when we look at our yx is here. The y is the kinetic energy of the photon, and here is our x is the frequency of the incident light. Okay, so whoopsie. So that's going to give us an idea of how we want to set stuff up. Okay, well, ladies and gentlemen, let's just start by rearranging this to get this as y. So I'm going to minus my work function over. So my EK is going to equal the energy of incidence, whoopsie, wrong sign, minus the work function. Okay? So, well, ladies and gentlemen, remember that the energy going in is going to equal HF. Okay. Now remember, previous equation, you can find that beautiful equation in your data sheet. Okay. Which is going to be, of course, I can't find it. It's Monday. There we go. Right up there. Okay. It's not even Monday. It's Tuesday. I can hardly say that. Okay. But we do anyway, because everything's Monday's fault. So, ladies and gentlemen, noun minus our work function. Okay. So, ladies and gentlemen, let's now think about this here. F is our x, ladies and gentlemen. So, EK is going to equal, oops, well, guess what? We don't actually have to do any more. I was about to already start breaking everything up into y equals mx plus b. But ladies and gentlemen, we don't have to do any more. So the EK is our y. We know this is our x, so the frequency of the light from our graph. Whatever's multiplied by the x is our m. And guess what here? Plus our b. So now this case, ladies and gentlemen, b is going to be negative w. Okay? I'm actually going to rewrite this a little bit here. So we're going to have, I can just do this here. There we go. So b is negative w. Okay, let's go back on our graph and confirm that we want w to be a negative number. So jump back up to our graph. Well, look at this, ladies and gentlemen. We do want b to be a negative number here. Okay, so that is a good thing. Wrong button. Scroll down. Okay, so ladies and gentlemen, we see here, now this is our m. So therefore, our slope is going to be Planck's constant. Sounds good? Awesome. So we've seen that graphically and mathematically, and now we've seen it algebraically, y equals mx plus b. Excellent. So now b, what is the meaning of the y-intercept? Well, we've also answered that with this equation here, so we don't have to do any more work with that. More work with that because b is the work function? Yeah. So we don't have to do any more work with that. We're just going to put in our, so your b is the value of negative w. Sounds good? So your negative work function. All right. So, ladies and gentlemen, so that's m equals and b equals. Now C, what is the significance of the x-intercept? Well, let's go and look back up at our graph and see what we've got there. Okay. Well, ladies and gentlemen, let's think for a moment here. Now, this here is the work function. From here until here, we don't have any energy in the electrons. Okay. This from here to here, that is the energy required to knock loose that electron from where it's held via its attraction to that proton on that atom. So therefore, ladies and gentlemen, that what do you think would be significant here as soon as we start getting kinetic energy? And that's frequency. That's the threshold frequency. Isn't that awesome? I think it's pretty awesome. I think it's pretty cool. See, graphs are lovely things. They're beautiful. Anytime you do anything with physics, you can get so much out of a graph. And for those of you who are wanting to go and do more stuff with physics, and they'll be doing physics labs and post-secondary, you'll be graphing everything, I swear. Okay, so ladies and gentlemen, use your graph to determine the work function of the surface. Well, ladies and gentlemen, based on the graph I drew, not on here, the graph I drew off of the screen before I made the video, I got a value of B of being so negative B, negative 2.20 electron volts. So that means we make everything positive. So that would be equal our negative W. So if negative W is equal to negative 2.20, our W is going to equal to 2.20. So in that case, ladies and gentlemen, you just use the graph and you just go up to the graph and look at it. That's how I got that number. Okay, so back up. Okay, you can kind of see it here on the super messy graph we got here. The one I drew off screen was much nicer, got about 2.20. So that would mean on your graphs, which I'm assuming you've done before you watch the video, you'd be able to see about that too. And if you did this with your stat plot, you would also be able to get the B at that value there too. Sounds good, guys? I had fun with this video. It was a good time. Okay, it'd be more fun if we were in class. All right. So, ladies and gentlemen, do practice problems. Give some of those a try. And that's the end of the videos for photoelectric effect. And stay tuned for the next episode. All right. Now I need to find the off button. Okay, guys. We'll see you all next time. And talk to you all later. Bye.